Okay, so like I was saying, we're only meeting today, and then your periods 5, 6, and 7 will meet on Monday. And then next week, I will also have some new stuff about statistics when we have just 1 week after that. So if we were at school, we'd still have 15 or 14 days to practice with statistics. But because of everything, we basically have 3 or 4 Zoom sessions to talk about statistics. So this week I have posted 2 assignments you absolutely have to do. They are, what is a statistical question? There's 2 videos, it's 4 minutes long, and a Google quiz, that's 5 points. This right here, the Google Drawings, it's a card sort and it's for practice. And I will be doing that in this video to summarize. It's not necessary that you do the card sort, you have to do the quiz. The second quiz is what is statistics? There is, again, 2 videos, 6 minutes total, and a 3-question quiz for 5 points. After this video, I'm going to summarize what's in those videos, so you should be able to do the quiz. Then there is a question to answer. The video is 5 minutes, and you are just pulling 1 fact from it, or phrasing a statistical question mentioned in the video. Let's see, we have 2 answers so far. So Kaylee has said the U.S. has a highly decentralized statistical system, meaning 25 agencies spread across the country, spread across the government. It's really good. And then Presley has pulled out 1 statistic, over 630,000 deaths from heart disease in the U.S. So that's all you have to write for your answer for the statistical question video. And then there's this assignment in the current news, and I will talk about this at the end of the video. So basically, I'm doing introduction to statistics today for this week, and then next week we will talk about data distribution, the mean average distribution, mean difference, sorry, and then remind you how to find the mean and the median when you're looking at data. So in the first video, the one that you have to answer the question for, if this had been in class, you would have had some notes. So the United States is on a federal statistical system to collect objective information relevant to, this is a bunch of money, which is economy. The heart with the heart monitor is referring to our healthcare system. And this symbol here is to represent the government. So actually, more now than ever, we're seeing a lot of statistical information in the news because our government is having to make a lot of decisions and policies related to our public health care system and our economy. And those statistics help us make, some really big decisions that they've had to make recently about closing school, reopening stuff like that, right? The second 2 videos talk about the 3 big questions that statistics help us answer. This is not one of your quizzes. They answer, how big is it? How big is the problem? What difference does it make? And are you sure that it's not just a coincidence or that it's not just dumb luck? So they talk about 2 people in specific. The first one is Dr. John Snow. He lived in London in the 1850s. And in 1854, there was an outbreak of cholera, which is a disease, is a bacterial infection that causes you to have excessive diarrhea, so much so that you get really sick, you get dehydrated, and it can kill you. It was also a problem for pioneers in the United States going west in the 1800s. It's still a problem, but we have better ways to treat it, and we actually know what causes it now. Back then in 1850, Dr. John Snow didn't know exactly the cause. He kind of thought it was the air that caused cholera, but actually, it comes when sewage and stuff from the bathroom gets mixed in with your water source, and they were drinking bad water. They were drinking contaminated water from city wells. So he didn't trust it, but he did plot out all the cases and the deaths in the city, and he found this really big circle was right next to one of the town wells. And so all these people that were getting sick, it's because they were drinking from the water. No one knew that was why, and he couldn't necessarily show them it, but he could show them the map and say, hey, all these people around this well are getting sick. You need to shut down that well and not let them drink water. And he was able to use statistics to make his case. And that is actually was the start of a branch of medicine called epidemiology, where you use statistics to track the outbreak and the causes and things like that to try to figure out how to stop diseases. Something that we're doing right now, right? The other person the videos talk about is Florence Nightingale, who lived in Eastern Europe and was a nurse in the Crimean War, which is near Russia. She's known as the lady with the limp, but I actually know more about her for what she's done with statistics. So she used statistics to actually show that soldiers were not dying from their actual wounds, but from infections they were getting in the hospital. So in her pie chart, it's like a histogram / pie chart. The pink parts are soldiers who have died from their actual wounds. The gray part, the light gray, is soldiers who have died from infections they got in the hospital. So she was able to go to the hospital board and say, hey, people are dying from infections in the hospital, much more than they are dying from their actual wounds. We need to do a better job at keeping the hospital clean. So there's like a 1-minute video about it. It's like a poem. And it's like, she shouldn't be called the lady with the lamp. She should be called the lady with the pie chart. So these are examples of why statistics are really important. And of course, why they're in the news right now. It's not just for health. It can be if you're into marketing or a business. Statistics are good to figure out who you want to advertise to. Or if you are a business owner, statistics can help you figure out what kinds of things you need in stock in your store and things, all sorts of things, right? Okay, so that's the real world application of statistics. And actually, I said I was going to go back to that other assignment, and I'm going to do that now since I just talked about John Snow and Florence Nightingale. So I kind of summarized it again with Florence Nightingale and Dr. Snow. This was the start of modern epidemic. I lost my question. Hiccup. Why? Why is this happening? I didn't want us to do that. Okay, starting again. Statistics, Florence Nightingale understand why soldiers are dying so much in hospitals. Dr. Snow was able to stop the outbreak of cholera in 1854. This was the start of modern epidemiology, the branch of medicine that looks at how often, where, and how to control the spread of disease. Since we are in the midst of a public health crisis, we are seeing epidemiology in action. Data is being collected and policies are being made to try to control the spread of COVID-19. Through the linked Padlet, I want you to upload a screenshot of a statistical graph, a chart of numbers, or a map, and explain what statistical question the information can answer. Please also copy and paste the link where you did. Then if you have other questions for me about the information that you're seeing, you can post it in Google Classroom. Or if your answer is here, that's okay too. Kaylee said she found an appendix with an overview of the statistical system as a whole for objective empirical information on a particular aspect of the economy or society. At the center of the federal statistical system in the OMB Office of Information and ... the Bureau of Economic Analysis. So she clearly copy and pasted, a description of something found. She used the ... to make it shorter, which is good. It would be also really good if she had a copy of the website address you use. So you can put it there, but you can also go to the Padlet. And hopefully you've used Padlet in your other class. I have used it for, it's not in this class. Click on the plus sign to add your thing. So in the title box, you can write the question, and then underneath it, you can put a description. So this was my example. I found this map here on the New York Times. And the question that it could be answering is, where are people getting sick? Or where are people getting sick the most? I have a pretty long summary. Yours doesn't have to be so long. I said, this is like how Dr. John Snow plotted the number of cases of illnesses in his city. The chart shows how many people are sick from COVID-19 based on where they live in the United States. This can help us think about how the virus is spreading. I just want to point out on this map, you have to be careful because they are showing total numbers, but you have to also kind of keep in mind that 94,000 in California may not be as big of a percentage of the population as, say, 37,000 in Louisiana, or 5,000 in Arkansas isn't as big of a number. There's just not as many that live in Arkansas. There are millions and millions of people that live in New York City. So you can see the big bubbles around New York City, Boston. This one in the middle is Chicago. This one in California, Southern California is LA. I can also tell you, because I'm from Michigan, that this big bubble in Michigan is Detroit. And this bubble here in Utah is Salt Lake City. The bubbles in Colorado are probably around Denver. So you can't always compare the size. You can't necessarily say that there are more people sick in New York City than LA unless you know the percentage of the population that's sick, and this map isn't showing that. Seattle's up here too, but it's still important to look at that. Sometimes you can say, like, there might just not be a lot of people living in Montana. This other example, this is a pretty good one. These two others are pretty good. So Julian said that this graph is answering the question of how many people have died or dying from COVID-19 in Maryland. The chart shows how many people have died from coronavirus from March until now, and it's good to know this so we know how to treat people in the hospital. So you can see that it started in March, it got pretty high in the middle of April, and it has started to come down in May. It is showing, you can see it says deaths, and it's got confirmed cases, confirmed deaths, and probable deaths. So this is why in the news we've heard that Maryland is reopening. But then Roberto has this one. His question is, has the increasing of COVID-19 stopped or slowed? In this graph, it shows how many cases there has been in a form, like a timeline per day. This actually is our county, Montgomery County. And you can see, again, starts in March and it goes up. And there's a couple of spikes having to do with like record keeping, but it's still kind of high. Or it's starting to level off, but it hasn't gone down yet, which is why in Montgomery County, things have not quite reopened. So those are actually two really good examples. If you have trouble getting a screenshot, like you just take the screenshot, you can upload it, or you can drag pictures into the Padlet from other tabs. If you're having problems with the pictures, it's okay to just put the link in your summary. But the pictures are interesting. I like looking at them. It's on the Padlet, we can share the pictures and everyone can see it. If you just do it in Google Classroom, other people can't see you can't upload a picture and other people can't see it. Okay, so that's statistics in real life, right? But if you're just doing a small statistical study or something and we were doing just some small practice in class, we have to start with collecting data. Actually, I always like doing in class because, you know, it was fun to like ask everyone how many siblings they had or something and then plot it out on a, I don't know, a dot plot or something. But I only have 3 Zoom sessions to go over this, so maybe one of them we can do that. I don't know, do we have time? Your next assignment that you have to do is what is a statistical question? So I wasn't being very picky on the Padlet, but the thing of how many people have died from COVID-19 isn't the best statistical question because that makes it sound like the answer. I could give you the answer for today, right? And there's one answer. So it's not really a statistical question. But if you said, how many people have died from COVID-19 since March, we can trace how many each day. You'll get different numbers every day. So if it is a statistical question, then you will get many different answers. The answers that differ have variability, and it might be a big variability spread out, or it might not have a lot of variability clustered. But if there's only one answer, then it's not a statistical question. If there's more than one answer, it is. I'll give you a couple of examples. If the question is, how old am I? It is not a statistical question because I'm 36. There's one answer. But if the question is, how old are race car drivers in the United States? You could get anything from 20 to 40. Or how old are professional soccer players? You'll get a range of ages. How old am I? Not a statistical question. How old are basketball players in the NBA? Statistical question. How old are the students at my school? That is a statistical question. It's not a huge variability. It's probably between 10 and 14, but it is statistical. Couple other examples. What is your phone number? Not a statistical question. How many phones do people on my street have? That you could get a variety of answers. 0 to 2, I don't know. The next one, how many televisions, but maybe today I would say how many mobile devices does each family on the street own? That would vary from 0 to 5 or something, right? I could ask you, how much did you pay for your last hamburger? That wouldn't be statistical. But if I said, how much does a hamburger cost in Silver Spring, Maryland, then I could go find out how much it costs at McDonald's and Arby's and BGR and some places, restaurants. You can get, and they would all have a different price. So it would be statistical. The last question, how many brothers and sisters does each student in your school have? That would vary. If it was how many brothers and sisters does Ms. Carbon have, it would not be statistical. I could just answer your question. And you can have a high variability or a low variability. So how old are people shopping at the mall? Could be anywhere from a baby to someone who's really old. You could also say, like, how old are people who die from COVID-19, right? And you'll still get a range, but it might be more like 30 to 80 or something like that, where we've noticed that more people who are older are more likely to die from it. So that's the difference. You can have really low variability, like how old are students in the 7th grade or the 6th grade. It's gonna, 10 or 11, 10 or 12 or something, huge variability, versus how old are people at a store or something like that. So I have some examples, and just think of it as a practice test for yourself. If you can click on yes if you think it's statistical, and no if you don't think it's statistical. Okay? And then there are some that are kind of in between, but I'll tell you what I think. Okay. How many siblings do students at the school have? Is that a statistical question? Yes or no? So if I asked one person, they might say they have 5 siblings. And then if I ask someone else, they might say they have no siblings. So you can get a range of answers, and that makes it a statistical question. If I ask you how old are the students in my school, you'll get a range of answers, 10, 11, 12, 13, 14, 15. So this is statistical. I already gave you this example. How old am I? Is not statistical. How much do backpacks weigh? I could take a bunch of backpacks and I could weigh them, and you would get slightly different numbers. So it is statistical. What are students' favorite football teams? It doesn't always have to be a number to be statistical, as long as you get different answers. So you have Ravens, Steelers, Eagles. It is statistical. What is the most popular ice cream flavor? Now this one's an in-between example, because if you just say what are popular ice cream flavors, or you say what are students' favorite ice cream flavors, you will get a range: chocolate, vanilla, mint, Rocky Road, lots of different kinds of ice cream. And then, but it says what is the most popular ice cream flavor, you could probably find out that it's one specific ice cream. So this one is yes and no. It's not a well phrased question. Also, how far can I jump? This one is still statistical though, and it's one that I recommended you actually try out, because you can do it at home. But you have to jump like 5 or 10 times and measure it. But you'll get a different answer each time. How old is the principal? Not statistical. She also probably doesn't want you asking. What is the favorite subject of 6th graders at my school? That's statistical. You can get different answers. How many cubes can be stacked in 1 minute? That is statistical, and it's also one that I suggested, because if we had been in school, I would have actually given you a bunch of cubes, and I would have had you see how many you could stack in a minute. And then I probably would have had you do it again, and probably would have done it with a printer or something so they could time you. And then I would have collected everyone else's groups, and we would have graphed out all the data so we could see how many you could do it. But each time you do it, you'll get a different answer, because sometimes you'll be faster or slower than others. How many text messages do students send every day? Is statistical, because it depends on the day. Also, you're going to get a lot of different answers. This one, are cars speeding in the school zone? It's not the statistical question, because you're going to say, how fast are they going in the school zone? And that would be statistical because different speeds. But if they're over 30 or not, then it's just a yes or no question. So that one's what zip codes do students in your school district live? That's also a yes or no one. You might have more than one answer, but it's probably only 1 or 2. How many brothers and sisters does my best friend have? That one's not statistical. There's only one best friend. What is my favorite color? Also not statistical, because it's orange. What is the distance from my house to the school? There's only one distance, because I live in one place, so it's not statistical. How many years have students in the school band or orchestra played? That's statistical, because you're going to ask a bunch of students and they're going to give you different answers. What are our favorite colors? That's statistical. Who is my favorite movie star? Not statistical. And can I roll my tongue? Not statistical. There was another statistical activity that I suggested that you do at home, and that would just be flipping a coin. So if you flip a coin, 50% of the time you should get heads, and 50% of the time you should get tails. But actually, when you do it, you won't always get 5 and 5. Actually, I should do that right now. I have a coin. This is not a regular coin though. This is not a regular coin either. Okay. At first, I pick up I don't know, a Denmark coin and like a Swedish kroner. Okay, so I have a quarter. One side is heads, one side is tails. If I flip it once, it's tails. I should get tails 5 times and I should get heads 5 times. I'm gonna do it 10 times. Tails, heads, tails, 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 heads. I'm going 2 more times. Heads, tails, heads. So I got 4 heads and 6 tails, even though theoretically I should be getting 5 and 5. Now the thing with this is that I have to do it a bunch of times. You can't just do it once. If we were in class, then everyone would do it. We compile it. I will do it 1 more time. So you'll see that I don't always get 4 and 6. So heads, tails, tails, heads, tails, 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 tails. 1 more time. Tails. So that time, I was just really lucky with tails and I got it 8 times and heads twice. So I would need to do this at least 5 times or maybe 10 times. And if I add them all up together at the very end, maybe it might come out to 50%. Actually likely that it would, the more times I do it, the closer it'll get to 50-50. However, I'm not going to spend all my video doing that. So that means for this week, you have the 2 quizzes, Intro to Statistics and What is a Statistical Question, and the Padlets. Next week, we will do mean, median, and mean average distance, as well as data distribution. Okay, and those are the main topics for statistics. The last week will be about getting everything turned in and review activities. I'm gonna end the recording now. If you have any questions, please email me, okay?
Oh, okay.